know where I'm at. And it says Newton's third law. Now, Newton's third law can be summed up as simple as for every action, there's equal and opposite reaction. So, for instance, when I throw this ball down on the ground, there will be an equal and opposite reaction making you propel back up. Like so. So, with that said,
how many points I get for that?
Well, this was the board was 15, right?
I got my rest of it. I got the rest of it.
So again, all I'm doing is I'm utilizing or exhibiting Newton's third law. So if I hit this on the ground, it's going to come back up, and it also depends on how much force I threw the ball with, right? So if I just drop it, it's not going to come as high as you see. If I do that, it exerts the same force back. We're going to see this with the canoeists, right? So now, in the problem, the canoeists, they're in the middle of the lake, right? So when they're in the lake, where's my marker? What happens is, say this is canoe 1, right? Full circle, and this is canoe 2. What happens is they're telling you in the lake, they push each other with force of 68.3 newtons, right? So turn the page, once you get that box typed up, turn to page 159. Now let's talk about some things known and unknown values. Before I do, keep in mind we're using Newton's second law, but we have multiple forces, and we're talking about what happens when the forces react. So, when I'm saying react, the force is going to go, let's call this 1, let's call this 2. These forces are going in opposite directions. Okay? So, this is your we do. Okay? And we are still using Newton's second law here. You might as well say for multiple forces. Second law. Alright? But this is with third law being utilized. So Newton's third law is also used here. Okay? So what does it look like? Well, we know F is equal to M times A. And if you find one force, that means you can find the other force because it's two forces propelling each other. So what you're saying is you can say force 1, I guess you can bring these notes so you understand it, is equivalent to force 2, but only if it has an opposite effect. Okay? That's Newton's third law inside of this second law. Right? Or you can say on top of it. So let's move forward. Let's go to our known and unknown values so we can figure out what we got. So we're going to consider canoeist 1, force 1, canoeist 2, force 2, right? The book does force 1. You know, the book does this where it's in negative. I think it's the way the book is here. So let's say this is negative. There we go. And that's how the book does it. I want y'all to follow the book pretty good. So 159 is where I'm at. Just look at the page. It's called the problem is Tippy Canoe. Tippy Canoe. And you can look at the visualization of what's happening with these canoes. One's going this way. But they literally are pushing each other away, right? So now we got that set up. We can say our known values are. And anybody get a few points they can identify what those are. We got two forces we're concerned with. So what would be the first? Not N, F. In this case, if you look at 159, it's going to be F1 for canoeist 1. So it's 5 for you. When she says 68.3 newtons, right? Now, I messed up because this is supposed to be negative, right? So he's pushing away. So basically, forces will be repelled. Well, like I said, and again, the book tells you this is to your left. So they're going to the left-hand side of the lake. The right-hand side is going to be positive, which might make sense on the x-axis. So you got F2 is going to just be 68.3 newtons. Okay? Now move a little fast because again, I want you to have time to do your on your own. You got masses here. And they tell you some of the masses in the problem. So yes, now we consider your mass 1. 5 points. So that is 183. It's 19 kilograms. And we got the other canoes, right? So what was their mass? Well, so the problem here.
M2 equals 321.89 kilograms.
Very good. 5 more for you. 321.89 kilograms. Right. How about unknowns? What do we not know about the problem? What's really not obvious? Or what's the question asking you? Well, pretty simple. We're looking for acceleration of both the canoes. Right? So we got to do two things. We got to calculate canoe 1, the acceleration, then canoe 2, what's going on with it. Real simple, we know our algebra. So we're going to say, hey, we need the acceleration for the first canoe, which is going to be meters per second squared. We need the acceleration for the second canoe, which is something in meters per second squared. All right. So I'm going to do some algebra and figure out both of these values. So to get this done, we just say, hey, let's call this part A, beginning step. Solve for the acceleration of canoeist 1. Canoe is like, I don't know if you're canoes for this.
That is easy.
What, this A, right? A1. So what's it doing? Right? Just put it together, right? You know you need the force of 1 is equivalent to, just match it up, the mass of the first canoeist, right? And then this will be what it needs to get close to the acceleration of the
Is
first.
that a mass 1?
Yes, M1. And time. So I matched it all up because we're trying to find A1, right? Now right again, we got to do some algebra on it. So force 1, mass is equal to mass 1 times acceleration of the 1. And then again, I got to isolate it. So I got to do some algebra. These are the steps that I'm going to show you in the book, but you need them on your paper. So I'm just going to remove the mass by doing the opposite multiplication. And I can say M1, and don't forget what you do one side and the other. You cross out your masses. And we write the equation. And now we're everybody's favorite part, plugging the numbers, right? Time to plug in the numbers. So we have acceleration 1 is equivalent to force 1 divided by mass 1. So, Joe, you get a chance to see if it captures the side of the board or it's just over here. I don't know how you place it. So let's put the numbers in. We got A1 is equal to our force 1, which remember it's negative because it's going to the left and not the right. So that's 68.3 newtons. All divided by the mass, right, itself. And the mass is right here. Mass 1. So that's 183.19 kilograms. Okay.
I can't even see.
The zeros in the wood.
No.
So let's see what A1 is. Okay, grab a calculator or somebody can tell me what's in. Nobody? All right, I'm gonna. So looking at this, we have, let's see, clear. So we're gonna say fraction, like boom. Hey, see it here. You're messing with me. Negative 68.3, come down 1, and it's 183.19. And that is equivalent to negative, it's an acceleration, so it's really minuscule change. Negative 0.337, is there an 8 there?
Can you see?
2 8, so just 3. And this is meters per second squared. All right, I'm going to do part B over here.
Yeah, do part B.
Because I can't go south. This is like how low can you go? Because I can't go that low. So come over here.
How low can you go?
Yeah, you remember that, huh?
Can you
all right, so y'all so comedic. All right, part B. Again, you got to solve for the second canoeist. So use the values that are respective of that canoeist. So this is for A2, right? Well, in A2 you have F2, just match it up, is equal to your what? M2. And I'm not going to take you through the algebra again, I'm just going to put the equation for it, right? Because I think we understand the algebra line. I don't want y'all typing too much. A2 is equal to your F2, and this is based upon the algebra you can do over if you want. But you definitely have that algebra steps here, not over here. You're going to jump to put the numbers in. That's what everybody likes. then y'all have too much to do. So A2 wins at the shorter schedule. We're gonna use this value, right? So that's the force here. This one's a positive.
Speed it up.
You said what now? And then M2. 89 kilograms. So that leaves a result or a yield. Let's go ahead and calculate that out. Fraction button.
I know how to work the calculator now.
You know how to work it now?
Yeah.
Awesome.
Hey, nah, I'm talking about these. JB, stop talking to me. For real. I'm not talking to you.
I got like a love-hate relationship going on. Alright, so that is a yield of, this is the E numbers engineering, so I'm gonna hit enter and get this regular number for y'all because y'all like engineering. So it's 0.212.
Can't even see your computer.
And this is meters per second squared. And that's all she wrote, okay? So type it up. Try the same steps in you do. You got 2 you do problems.
It just changed the number. That's all you do.
That's really all you have to do. Some people, I don't know, get scared. Okay, let me get that phone, stop this, and then we're gonna set a clock for how much time you got left. This was the problem in case students were wondering. And that's pretty much